So next is a pretty big topic. We look at it over and over again in schools. It comes up as we get more and more complex fractions. But it's deciding which fractions, bigger or smaller, if they're equal, equivalent fractions is a big deal. I'm going to start with these equivalent fractions. So I'm going to draw some pictures. So visually, we're just going to be looking at, and I'm going to show that 1/3 is equal to 2/6. And that is a true statement. They are both equal to each other. I could reduce 2/6 down into 1/3. Lots of different ways to show this visually. I'm going to draw maybe like 2 different ways. I'm not saying they're the only way. So to do this, I'm going to make an area model. So make an area model of 1/3. To really compare, I need another area model that is exactly the same size. If they're not the same size, I'm not really proving that they're the same fraction. So here's the area model. That one's a little bit wider. Let me see if I can. There we go. But I'm going to make this one into 6. So what this shows is that these two take up the same amount of space. For this to work, your area models need to be the same size. You can't make one larger than the other. For instance, I sometimes see students do this. They'll give 1/3, and to make the 2/6, they'll just make it like twice as long, and then say that that's 2/6. This is not the same size. This first one is much smaller than the second one. So that does not prove to me they're the same size. It actually makes me think 2/6 is larger than 1/3. So you want your area models to be exactly the same size. If you don't want to do it on 2 different area models, you could just do on 1 area model. So again, I'll draw that 1/3. And then on the same area model, I could think about it in terms of 6. So this blue part, I could think about being 1, 2, 3, 4, 5 as 6. It would be 2/6. Or if I thought about it in terms of just thirds, it would be 1/3. So you can use like kind of a 2 area model approach or a 1 area model approach. And we also want students to be able to do it computationally because we can't draw pictures for everything. So I'm going to look at a couple different ways that we could compare. So I'm just going to compare 3/4 to 7/8. One way we can do this is by cross multiplying. So by cross multiplying, people love to cross multiply. Sometimes it's called like a butterfly method as well. We can do our cross multiplication. 8 times 3 would give me 24. 4 times 7 gives me 28. What I've actually done here, I'll show you in just a second, is get a common denominator. And that common denominator is down here, 4 times 8, which is 32. So this is kind of called a butterfly method sometimes because you got 2 wings. You might have your little antennas up here. What I've done is I've said that 3/4 is the same thing as 24 over 32, and 7/8 is the same thing as 28 over 32. This gets a common denominator. It doesn't give me the least common denominator, but it does get me a common denominator because it multiplies one fraction by the other side's denominator. So when I could do this, I would see that 24 is less than 28, so I know that 3/4 is less than 7/8. Just to kind of show you again, what this little pattern did was it multiplied one fraction by 8 and the other fraction by 4. So it just multiplied by whatever the other denominator was. It does it kind of in a cute way with that cross multiplication, with that butterfly method to help you remember how to do that. But that is what it's doing, is getting a common denominator. Now, it's not the least common denominator, but it was a common denominator. So another way to do it, I'll keep this same problem, is to get the least common denominator. The LCD is what it's called a lot of times. The least common denominator denominator between 4 and 8 is 8. So I want both of these to have a denominator of 8. Well, one of them already does. The other one, to turn 4 into 8, I'm going to multiply by 2. What I do to the top, I do to the bottom to keep it even and equivalent. So I get 6 eighths. So what I would really be comparing is 6 eighths to 7 eighths, and 6 is less than 7. So that means that 3/4 is less than 7 eighths. So you've got two methods there. One is just getting a common denominator, or it might be cross multiplication or butterfly method. And then you have another one where you're getting the least common denominator. Now there is another option for some problems, not for this particular problem, but if we have fractions that could be reduced, we can reduce them down and see if we can compare them then. These fractions were actually already reduced down, and I needed to make them not reduced. So let me give some space here. I'll give us a new problem. So say I had the fraction 12 over 42 and 10 over 35. Both of these could be reduced down. So if your fractions can be reduced, you should try to reduce them down. That way you can see what's really going on here. So 12 over 42, both of those have a factor of 6. So 12 is 6 times 2, and 42 is 6 times 7. So that reduces down to 2/7. It's a different factor for 10 over 35, and that's fine. They both have a factor of 5. 10 is 5 times 2, and 35 is 5 times 7. So they don't have to use the same factor to reduce down, but just reduce each fraction as much as possible. And then sometimes it's a lot easier to compare. Maybe not, it might not be the easiest, but if you did reduce it down, you might then could find a smaller common denominator or something to make it a little bit easier. So if I reduce these down, I can see that they're actually equal, even though I didn't look like it at the beginning. So 12 over 42 is equal to 10 over 35.